Trustees, Executive Committee, and members of IWSA. I welcome you all today. I take this opportunity to briefly introduce our organization and today's Science and Our Life program in a nutshell.
Hello.
Our organization is in its 52nd year, based in Vashi, with 12 branches across the country, with the goal of bringing scientific temper to the community and women empowerment. We have two wings through which we conduct all our activities. One is science awareness and other is community welfare. A large number of activities happen on campus, and we have the Working Women Hostel standing tall with a capacity of 160 beds for young working women who find it as a home away from home. Besides this, we have a daycare center, a nursery, a library, healthcare center, computer education center, a science lab, ECCE, that is Early Childhood and Care Education Program, which is a diploma program tailored to become nursery teachers or pre-primary teachers, and many others like scholarship facility to the meritorious and financially needy, and internship program both with the schools and colleges. With one of our mandates to popularize science education through lectures, exhibitions, and competitions, today's Science and Our Life series, supported by Board of Research and Nuclear Science, is one such activity which was conceptualized to bring to fore how science has influenced and shaped our lives, be it health, finance, education, environment, history, and architecture. IWSA's endeavor is to invite eminent scientists and personalities on this virtual platform and explain the interesting facts in a simple manner. And today we are privileged to have Dr. A.V.R. Reddy, Chief Executive Officer, Gemmological Institute of India, on the topic, The Science of Gemstones and Diamonds. He holds an illustrious career path and an accomplished scientist who was conferred with Dr. M.V. Ramaya Lifetime Achievement Award for the year 2021 for his contributions to radiochemistry and allied sciences. He joined Nuclear Chemistry Section BRC and was head Nuclear Chemistry Section and was also head Analytical Chemistry Division. He worked as a professor in BS University in Nellore for a year, and he did his postdoctoral work in University of Mainz, Germany, and worked in the International Atomic Energy Vienna during 1999 to 2000 as a technical officer. His areas of research are nuclear fission, nuclear reactions, nuclear analytical techniques, non-destructive assay methods, etc. He has about 300 journal publications, and he has delivered more than 500 lectures in India and abroad. He is an active member of many scientific associations and was president of Indian Association of Nuclear Chemists and Allied Scientists Association. Dr. Reddy is a fellow of International Union of Pure and Applied Science, and he has worked with two funding agencies, including Board of Research in Nuclear Sciences and Science and Engineering Research Board. Let us welcome our speaker today, Dr. A.V.R. Reddy, on this virtual stage today, with mostly we women audience here with an obsession for stones. We are eagerly waiting to hear your session, sir. The screen is all yours. You may please start, sir.
Yeah, you will be slides.
Yeah.
Yeah.
Yes.
Next slide, please. So the topic already has been Dr. Jock introduced, and I'm thankful to you for inviting me. Let us move on. And I would like to show the Gemmological Institute of India a photograph and then move on to the topic. And I'm very happy Dr. Mittal is seen, Amara Guru. And as far as the plan of the presentation is, I have written here, and though the topic is science of gemstones and diamonds, most of the times it will revolve around the testing of gemstones and color stones and diamonds. So it is a part of our regular duties. So I have listed all the topics here, what I will be covering. Hopefully, I'm not very sure of initial troubles. Are you changing the slide, please? Hello? Yeah. So, am I audible?
Very much,
Yes?
sir. Very much
Okay.
audible.
Fine, fine. Now, about Gemmological Institute of India, I would like to share a few minutes. This was founded in 71. It's an institute with a primary mandate to serve the J&J industry, for which we developed harmonized procedures and we use basic and advanced techniques. Our results are comparable to international levels. Unfortunately, I have put the animation here, so you have to change. Sorry, you have to go on clicking. You can click one time. Yeah. So essentially, as I told you, the traders and GI are beneficiaries, but this provides us challenges for continuous improvement through R&D, definitely provides us finances and satisfaction of serving the industry. Besides, JI is renowned for education and training. Our hands-on training is of international standards. Fresh students and trade aspirants get benefited. We are recognized by Government of India as a scientific and industrial research organization. And recently, just in the beginning of this month, we got recognized by NABL by the accreditation certificate. Next slide, please. So what do we do? Just to give a brief introduction, we characterize loose gemstones and diamonds, as well as when they are studied in jewelry. You have to click on, please. Sorry. So what do we have? We have expertise, equipment, trained personnel, and a small R&D team with lots of opportunities to work, though that is not the main mandate. But we believe in collective growth as well as develop mutual trust and confidence. Confidence, not confidences. Okay. Next one, please. Yeah. All of you know, as Dr. Jacob introduced, that the attractive appearance is of main theme: color, transparency, luster, brilliance, and the patterns. Obviously, since we are talking about the all optical phenomena, our instruments also, please click, our instruments also are revolving around the optical properties. Can I? Yeah. Okay. This sentence you read as it is, people are fond of wearing ornaments, more than that, interested in investment, gold, diamonds, and gems. And lots of beliefs are there in wearing birthday stones and acquiring Navagraha stones. This keeps our institute alive, this industry as well as our institute. Since it's a big money business, so certification, whether the stones that are purchased are natural or synthetic, is a requirement, because of which our institute is existing. Next, please. Yeah, this slide is important to understand the color. Crystals, all of you know, are very compact, have compact structures. Diamond is having a hardness of 10 more units, but yes, yet 66% of diamond is empty space, empty space. This provides us, please click, continuously click, please, 3-4 times. This gives a scope for accommodating other atoms or ions. And because of that, there is a possibility of forming different color centers. And if you click on the carbon by nitrogen or boron, hyperlink will appear on the periodic table, please. Yeah. You please remember that diamond is one element material, carbon. To its left, boron is there, and to its right, nitrogen. As you know that in the villages particularly, neighbors enter into your house by just knocking in, no telephones, nothing. Like that in carbon frame, nitrogen can enter as well as boron can enter. Inevitably, nitrogen and boron often are present in diamond matrix. Because nitrogen having one electron more, it will create an energy state which will lead to lowering of energy that will result in color. Though it is not obvious to the eye, instrumental methods can determine. Whereas in the case of boron, a similar system exists, except that the level is very close to conduction band. So that those diamonds are also in principle colored, but you need good instruments to decide. Similarly, if we move to the first line in the periodic table, starting with scandium to zinc, those transition elements, if they are present in color stones, then they will also create the color in the compound that we talk about. For example, chromium in ruby, that corundum, there is alumina. And similarly, titanium and iron couple in corundum creates sapphires and so on and so forth. So these 10 elements, boron, nitrogen, and silicon, with similar properties to central atom, are the main reason for the colors. Besides, some defects that are formed during the polishing of these diamonds. Yeah. So whenever other elements enter the network, like carbon network, suppose nitrogen enters, it will create imbalance in charge as well as size. That results in color center formation. I will show you at some point of time with the band structure. For example, in the ruby, the band gap is 2.3. That is the gap between the conduction band and valence band. And if chromium is present, this will scatter the red color and ruby is formed. Similarly, in the case of emerald, presence of chromium 3 plus will reduce the band gap to 2.5 EV. That will result in green color to emerald. Next slide, please. Next slide, please. Yeah. As already explained, presence of transition metals, either as a major component or as impurity, leads to formation of the color. And if the color is because of the presence of one of the components, it is called idiochromatic type, that is self-colored. If externally impurity is present, like chromium in ruby, they are called allochromatic. And in the case of diamonds, there is no need for the presence of transition metal, yet you see the colors because of presence of a hole, that is a lack of electron, or an extra electron. So these are the causes for the color. So now let us move to the next slide, please. I am giving in the coming 3 slides some examples. Idiochromatic, one of the famous examples is peridot, rhodamite, rhodochrosite, and particularly copper-based ones. Here, one of the major components is transition element. That is the reason for the color. Next slide, please. This is a beautiful one. Corundum as such doesn't have much of value in terms of the price, but the moment 1% or a bit less than 1%, chromium 3 plus is substituted in the lattice, then it will give beautiful red color. That is ruby. Similarly, in beryl, almost one of the cheapest minerals, if chromium is present, that is beautiful emerald. In addition to chromium, if water is present, then color will be altogether different, though it is green. Similarly, in the case of sapphire, you have a pair of substitution elements Fe2 plus and Ti4 plus. By exchanging an electron, you get the charge transfer situation like Fe3 plus and titanium 3 plus. And some of the chemists who are present there might be knowing that if the charge transfer is happening, then their extraction coefficient will be very high. Therefore, we get deep blue color for the sapphires. Corundum, and if impurities are present like iron and titanium, sapphires are formed. Next one, please. In the case of diamonds, there are no transition elements present. But you get colorless, which is most valuable. Similarly, colored diamonds also very valuable if the color is very fine. And this is because of vacancies and the carbon atoms which are knocked off from the lattice position, if they occupy the interstitials, then a vacancy will be created. Because of that, color can be produced. And this is one of the examples I gave here, green diamonds and 18 karat green diamond, which is natural. Yeah. Next one, please. So having understood, explained a bit about the color, and my friend Dhanya asked me to cover how natural gemstones are formed. I won't give the details. I would like to state, click please, that these are formed, whether it is diamonds or color stones. If you click once more, you will see a picture which I copied from internet. See, these are formed in the earth crust and subsequently in favorable conditions of high pressure and temperature, these color stones as well as diamonds are formed. And since in these hostile conditions of high pressure and temperature, this will exist as a hot fluid, there is a possibility that that surrounding elements can, as elements and ions, can as well enter the fluid. And if crystallization takes place, they will be carried through. And they help us in determining origin studies, means where geological origin, because their presence will tell where from they have come. These are all well-studied subject in geology. So we use that data bank and determine the origin of color stones. And GIA is known for determination of the origin of color stones, and this is the best institute for that. So I won't go into the details. Then similarly, hydrothermal deposits will lead to the formation of the color stones. I want to say that fluids can carry CO2 inclusions, water inclusions, and those things also will leave good signatures to be determined. Yeah. Once more click, please. And the last paragraph is most important as far as we are concerned. This process can be recreated in the labs. Being chemists, we know that all the known materials can be reproduced with some effort. A variety of processes can be developed as composition is known and have been developed. Colors can be manipulated by varying the dopants. Already we have seen the presence of the chromophores like chromium, iron, etc. will result in color. These treatments can be extended to natural stones also. But most of the manipulations leave a trail of signatures incorporated in the gemstones. That is the thing where a lab testing and certification is important, and these signatures are utilized. Similarly, diamonds also can be synthesized in the laboratory. Proceed, please. Next one. And synthetic gemstones are produced by many methods for the last 2 decades. And some of the methods are hydrothermal process, vernal process, crystal pulling, flux growth, etc. for the color stones. Diamonds, two methods you know very well, HPHT, high pressure, high temperature, which I will show a picture, but I won't explain. Another thing is CVD, even in BRC, some of our colleagues are working on that, of course, for technological applications. And this second picture shows a nice ruby, and you all know that ruby development actually has led to the ruby laser. The next one is, of course, emerald. Let us move on to the next slide, please. Yeah, this is again a picture about how natural diamonds are formed. Suffice to say that they will be carried through volcanic cratons. And I mean, all other things you can read yourself. This slide, this PowerPoint file is your property now. And after eruption, volcanic eruption, rocks like kimberlite, lamporite, carbonatites, and kamatites will be found with diamonds. In fact, they will be sort of tubes. There one can search for the diamonds. Also, these diamonds, by wear and tear of the rock, can reach the surface of the rivers. And one of the areas in India, like Panna or in Andhra Pradesh, people go in summer in search of diamonds. Lucky people do get some diamonds. And please remember that about 2.5 to 1.5 billion years are required to get these diamonds. And youngest ones may be 1 billion years. Because there is a lot of time while they are being formed and then in the fluid state, there is every possibility other elements can enter into this, particularly nitrogen and boron. If you take 30 metric tons, about about 1.5, I mean, we get only less than 0.01% useful material. Next slide, please, which I give some details. Next slide, please. Yeah. So, next slide, please. Yeah. To take the gist of that earlier slide, 100 to 100 kilometers below the Earth's surface, diamonds are formed. They are found along with these stones after the volcanic eruption, and 250 tons of rock excavated to get 1 carat of rough diamonds, of which, if we are lucky, 75% only will be retained after cutting them to a particular shape. Different cuts give brilliance, therefore cutting is important. Most of the diamonds are cut into round brilliant shape or cushion shape, RBC being the highest number of diamonds. And diamond structure is well known as cubic. It is the hardest substance. Next slide, please. Yeah, in the laboratory, click once more, please. As I was mentioning earlier, in the laboratory, two methods are standardized with success. Two synthesized laboratories. Now, diamonds are to be called as lab-grown diamonds, not synthetic diamonds. One method is HPHT, high pressure and high temperature, that is recreating the earth crust conditions in the laboratory. Other method is, and for which starting material is graphite. The other method is chemical vapor deposition method, in which CH4 is the methane is the starting material, and then with a low pressure of 10 to 200 torr, with a temperature of around 700 to 1000 degrees, we can break CH4 into carbon. And since H is all the time present in methane, so there will be H impurity. It is already, people have standardized to dope with boron and nitrogen to mimic the natural diamonds. And now CVD and HPHT are well established. In India itself, lots of CVD machines are there. In IIT Chennai, one Professor Rao was given 300 plus crores to construct CVD machines. Yeah, next slide, please. You will get the CVD picture here. And in the just to conclude this, the methods are well established. Now, gem grade diamonds are being produced by both the methods, though CVD is becoming more popular. And it started with the technological applications. Now, gem quality diamonds are also formed. And when you have to classification of diamonds, please remember the presence or absence of nitrogen is the central for the classification of diamonds. And if nitrogen is present, it is called type 1. Nitrogen is absent is type 2. Nitrogen present, if as single atom, then we call it as type 1b. But since years together, they are staying together, there is a busy possibility that two nitrogens exist around a vacancy. Such things are called type 1AA. If two of such pairs come together along with the vacancy, it is called 1AB. And all these three types, if one takes IR spectrum of the diamond, clear signatures can be seen. That is a boon as far as the testing institutes are concerned. Whereas if nitrogen is absent, it is called type 2. Nitrogen absence, one is natural, other one is artificial. Both the things come into type 2A. Whereas type 2B is the presence of boron, but together is less than 0.2%. So most of the diamonds do have nitrogen in them. Natural diamonds, when I say. Yeah. Next one, please. The biggest problem is simulants. Because in any trade, adulteration is common thing. I mean, so that one gets higher prices. Here also it is not an exception. For blue sapphires, some of the things I listed here, which can be simulants, spinel, zircon, iolane, synthetic sapphire, etc. For ruby, spinel can exist in different colors, so spinel can be one of the things, garnet, synthetic ruby, etc. For diamonds, cubic zirconia is the biggest problem. Incidentally, last year we developed a method to estimate traces of cubic zirconia in diamond powder and traces of diamond powder in cubic zirconia. And it was published and lots of appreciation is received. And synthetic rutile, YAG, etc., these are all simulants. So, Gemmological Institute of anywhere will have a responsibility to identify natural gemstones and diamonds. And this process is scientifically challenged because chemically they are all very similar or same. Suppose if they are LGDs, they are same. Yet there is a way to test and we certify them. And gemologically, a lot of interesting facets can be realized, and this is a big boon to the customers and genuine traders. So, necessity of certificate based on the observed facts is an important thing, and that keeps us alive. Next, please. Generally, optical phenomena-based instruments are used in testing gems and diamonds. There is no methods here. That is a mistake. Methods has to be removed. Diamonds. And, okay. I have listed here certain jobs, and later after this, I will just list a few instruments that we use here. Then I will present a few case studies. So precious stones are characterized by non-destructive testing methods. This all of you can realize. If you give me your diamond, you won't allow me to play with it. So we have to have non-destructive methods, and our methods should be developed such that as received samples can be tested. Examination is, first point is whether it is natural or synthetic stones. That is discrimination. Then next point is to find out whether it is treated or not, particularly color stones. They get treated to improve the clarity and to cover the fractures, etc. And in the case of diamonds, to improve the whiteness, lot of methods are developed, including use of the radiations. Of course, radiations are used to improve the color. And these things can be examined and identified also. And also these things provide us a chance to understand the processes. So we investigate to determine the geographical origin of the color stones. And in fact, we have quite a few publications on this. We published the data and explorable clues. For this, these are the requirements. What are the explorable clues? Physical properties like Ri, specific gravity, hardness, these are the fundamental things which we have to do routinely. That gives, first of all, those things will give certain information. Then optical properties, inclusions, types, shapes, and shades. These inclusions is a beautiful subject where microscope comes into use as well as Raman microscope we can use. I will show one example. And equipment that we can use is human eye, but not adequate. 10x loop, which if anybody visits our lab, you will be seeing a small sort of enlarger or loop, what we call 10x loop with everybody. Then, of course, microscope, but between 20 to 50x magnification. Then the spectrograph, it's a simple thing, but it gives a lot of information, particularly on the color stones. Then spectroscopic techniques we use, UV visible, since color we talk about, that is a workhorse in any Gemmological Institute, absorption. Then FTIR absorption, IR absorption using an FTIR spectrometer. Then laser Raman for both Raman effect as well as photoluminescence, subsequent photoluminescence. This is another workhorse. We all should be proud that Professor Raman's investigation has led to wonderful instrument that is in place in many, many instruments. Then for analytic, these are all based on the optical properties, whereas there are three techniques which are used for analytical determination of the concentrations: X-ray fluorescence spectrometer, laser-induced breakdown spectroscopy, and LA-ICP-MS for all for determination of the composition of the solid samples. And phenomena generally investigated are fluorescence and phosphorescence, which come under luminescence. And often we use only photoluminescence and Raman spectra, absorption spectra of both in the entire UV visible IR region, and relative composition we determine using these analytical techniques. All of them together are adequate. Is there any problem? Are adequate to
It's just a
determine?
disturbance from one of the participant. We will try to mute it.
Yeah. So these are all very useful for determining the type of diamonds or type of color stones, quality of the color stones, origin of color stones, and treated or not treated. Whether these color stones are treated or not treated, we can find out. If there are any inclusions, how they are covered, we can explain. All these aspects we can carry out using these equipments. Next one, please. Yeah, anyhow, this is elementary 10th class level. I just want to show that light as a probe, and most of the cases light as Mira, welcome. Mira, welcome. And reflection, refraction, absorption, and emission. All the techniques are used. It is a revision for most of you. So when a gemstone is exposed or illuminated with light, there is a possibility that it will absorb certain frequency. Consequently, the entire system will go into the excited state, that we lose the signal of the corresponding intensity, what we call absorption studies, whereas an excited system will relax back by emitting the light. And if you measure that emission spectroscopy, these two are very, very important thing to us. Okay, next one, please. And the same thing I listed here. I want to read the last sentence. Based on luminescence, GII fabricated an instrument. We named it as QCheck. In fact, my predecessor was the person who conceptualized it, Dr. M.D. Shastri, to discriminate natural diamonds from LGDs and simulants. And now we have brought out an updated version, which we call Division Pro, with more capabilities and more reliability. That's 97% is the reproducibility. Yeah, next please. I want to explain here that next version is Division Pro, we named it. And before I move on to the operation, about 500 machines we have sold. So everybody can test their samples in their lab. This Division Pro is 0 to and 15 seconds one has to expose to long wave UV radiation. Then it will emit a prompt fluorescence if this is natural diamond. At 15 seconds, take a photo, stop the source and take a photograph. And switch this to shortwave fluorescence and take a picture at 20 seconds. And phosphorus image can be captured after 30 seconds by totally cutting off the UV source. After 40 seconds, this machine has a provision so that all these three images as well as visible photos appear on the screen that has 4 quarters or quadrants. So from SW image, we can find out we can segregate the natural diamonds. From the phosphorus, we can segregate the LGDs. Remaining thing, we have to use our experience and knowledge. But we know there is no need for a trained manpower or qualified manpower to operate this machine. Therefore, we installed kiosks incorporating Division Pro for customers to operate themselves like we get the boarding pass in airport. And whoever is interested, you can visit our unit in BKC, that is, it is called Bharat Diamond Bush. It is available here. The photograph of the kiosk is this. You spread your diamonds, which are small diamonds, and you do yourself operate this and get the data. This is our contribution to G&J industry. Next one, please. And there is another equivalent unit, diamond view, which gives the patterns, but only limitation is principle is same. UV light is used to induce the fluorescence, and if blue color is there, it is natural diamond, and if it is orange yellow, it is CVD. Otherwise, you have to see as inert, you have to declare as inert. And next click, you will see. Click please. This is blue fluorescence image obtained in diamond view. It's not made by us, we procured. But the pattern suggests whether it is a natural diamond or not. Next one, you click please. This is a CVD which shows orange color fluorescence, and this is due to the presence of silicon vacancy. Silicon is synonymous with CVD because you use silicon windows, invariably silicon will be part of the CVD diamonds. By chemical methods, one may not determine, but our PL methods using Raman spectrometer, we can determine. We work quite a bit on SIV, scientific research also. Next one, please. Yeah, now move to the color stones and click, please. Yeah, once more. Yeah, we use the microscope, our colleagues rather, I don't use, but to see the surface inclusions. That tells about the quality of the color stones. Suppose crystals, if they are seen, small crystals, if they are seen on the surface of sapphire, its value comes down. You can see the rutile silk on the surface of the ruby and three-phase inclusions in emerald. Here I have to mention that you can find out presence of water. That is why compared to ruby and sapphire, which have the hardness of on the scale 9 Mohs, this emerald is softer, around 7.5 to 8. But it's a beautiful stone. So these inclusions reduce their price. Obviously, people try to wash them off, clean them, or hide them. If there are fractures, they treat with oil. If there are huge fractures, they treat with glass, that is lead. And in the process, those things we should be in a position to identify. We do identify. Next one, please. Yeah. Now, the list of equipment I am giving 4-5 are the workhorses which are being used in our institute. Every institute has to have. So, Gemmological Institute, I mean. So, since color of the gemstone is a fundamental attraction for using gemstones, UV visible absorption spectra provide clues about chromophores and thus will assist in finding out band gap from the cutoff. Next spectrum I will show chromophores, their concentrations, and indications of geological origin, or this can be derived from UV visible spectra. Next one, please. These are the typical UV absorption spectra of three types of emeralds from three different origins: Afghanistan emeralds, Colombian emeralds, and Zambian emeralds. Here you just see, I don't know whether my pointer is showing, this is the cutoff factor, which will tell if you convert this into energy, this is the band gap. And here the concentration of iron, chromium, and Fe2 plus will be known. These are the water peaks, what I was telling in emeralds. So by seeing the variation in these ratios, we will be in a position to identify the geological origin of gemstones. Yeah, next one, please. As I told you, IR spectrometer is a workhorse. In the case of diamonds, you see, you have this area I marked, all the peaks corresponding to different nitrogens and a consequence of a platelet, which I won't explain now, though I have a publication also on this. But these are the things which indicate that these are natural diamonds. You take a IR spectrum of LGD, this will be absent. So this is the phonon region, means that is because of the crystal structure vibrations. So these are the things, these indications are unequivocal, which we utilize. Yeah, next one, please. Yeah, we have 4 laser Raman spectrophotometers, one with 6 lasers, other one with 3 lasers, and with a confocal microscope arrangement, and 2 portable lasers, because this is the workhorse for us. And this is a must for characterizing any fission product, not fission products, finished products, not only gems and diamonds, but medical products. You talk about any material, this Raman spectrometer is a requirement. So we should be proud that our Professor Raman has discovered this. And Raman mode is a complementary to IR spectra, but a bit more than that, as this does not need resonance absorption. And PL mode is the best to determine the concentrations, believe me, 10 power minus 9 grams per 10 power minus 9 grams per gram or lower levels can be determined. And in fact, we have done this, right? All defects not all defects, most of the defects can be estimated using a Raman spectrometer in PL mode. Next one, please. See, my presentation is going towards the testing as the theme, but it is with a lot of scientific background. Yeah. So just for appreciation, PL spectra of one natural diamond and one CVD is shown here. Right side is CVD, left side is natural diamond. All the peaks that were observed could be identified, the corresponding defects we can identify, we can estimate. Similarly, in the CVD, you just see 2 peaks are very, very important in the current technological upheaval. 575 nanometer NV0, and in both the things it is present, and 737 SAV minus. These are the 2 defects. People are after it to develop the qubit. For supercomputers, this is required. Earlier, people thought SIV is the best. Now, somehow people are thinking NV0 is equally good. But a lot of work and publications are going on. But our interest is to identify. So we are happy with the SIV peak and NV0 peak for our own work. Yeah. Next one, please. This is the XRF spectrometer, another workhorse, where in combination with UV visible absorption spectra, we can determine the relative concentrations of chromophores with respect to the main element like aluminum in the case of ruby and sapphire. Otherwise, Again, aluminum in the case of beryl, and so on and so forth. They will tell us about the origin determination. Yeah. Next one, please. Yeah. So this is about the equipment, what we are using. And I just listed them to convey that these are the things we are using and day in and day out. And wherever it is possible, a bit of science I told. And some case studies I will present. Do I have about 10 minutes time?
Yes, please continue.
Yeah. So characterization methods and testing protocols in J are developed based on continuous scientific R&D. And in the process, we also get opportunities to carry out some fundamental studies. But again, fundamental studies revolve around testing methods only, because here our board doesn't recognize R&D, but they don't stop, fortunately. And Government of India recognized us as scientific and industrial research organization, as I told earlier. And a few of our contributions are listed and briefly will be presented now. And the three which I showed in the color have been practiced, and results are in the form of either certificates or publications for nearly 4 decades. Whereas the last three, that is 4, 5, 6, are during last 2 years we have done. And of course we have, we don't publish as, I mean, any other scientist. We do publish, but last three resulted in each one into 1 or 2 publications, and it's continuous work. I would like to go through quickly 2 minutes of each one. Yeah. Next one, please. Already I explained you XRF data along with UV visible absorption data are very useful to find out the concentration of chromophores. And the ratio of the chromophore concentrations will convey to us the origin of any colored gemstone we are studying. In the case of both origin, in the case of both, I mean, not both, all the three, rubies, emeralds, and sapphires, as I told earlier, we are the best institute in India. And basically, it could be possible because probably in our institute only trained scientists are there. All right. Now, in the case of rubies, as already I explained, main body is corundum matrix, and aluminum is replaced. If it is replaced by either chromium 3 plus or Fe3 plus, rubies are formed. And in the case of Burma rubies, for which price is in the sky, the iron content is very low. So because of the chromium domination, it is having deep red color, or what we call pigeon blood color. And this ratio among chromium and iron tells us that it is from Burma. Similarly, in the case of Madagascar ruby, iron content is quite large. And probably, I'm not very sure, the price may be 10 times lower, but I'm not sure about it, because we, as a rule, keep away from the prices. Otherwise, our interest may go in somewhere else. Yeah. Next one, please. In the case of emeralds, as I told you, matrix is beryl. Here also from XRF, we can determine the concentration of chromium and iron and vanadium. And vanadium presence, straight it tells that it is Colombian emerald, because it all depends on the geology there around. Whereas, if it is absent totally, it is Jambian emerald. Over and above, iron concentration also gives the support. So we have, and maybe each type we might have done about few tens of thousands of color stones origin, and that is the main income to us. Yeah. Next one, please. So the third case which I want to share with you is diamond grading. This is an issue where diamond grading is based on the 4 C's: carat, cut, clarity, and color. Carat is a balance business. This is very simple weighing. Cut, of course, to maximize the utilization of the diamond, people go for different cuts to obtain the brilliance, but at the same time, maximizing the diamond content is an important thing. So RBSC is one of the things. Actually, cushion cut, you save a lot of diamond. So these are the two main cuts that people use. It helps in improving the brilliance. So these two, by seeing them, you can find out. There is no big issue. Carat, of course, by weighing. Whereas the cut, we have a way to measure the different facets, and we have an instrument where it's called proportional scope, where it will tell it is the best possible cut or next best or the average or below average. The grading of this carat is simple weighing. Cut grading is it depends on the machine, very simple. And color grading is an issue where by seeing the diamond, we can determine with the 10x loop, we can determine, but we compare with the standards that are universally accepted. There are two bodies who supply this, who used to supply the standards. One is Gemmological Institute of America, GIA. Other one is SIBJO, Italy based. And both the standards we have, we compare with them. This is an art. Again, when you come to, if you happen to come here, particularly Mitosab wanted to come. Whoever wants to come, please come. I will explain these things. And I can also meddle with all these things now with 7 years experience. And color determination is easy, but the toughest thing is clarity. Clarity grading is very tough because this clarity can spoil the price. And this is due to the inclusions. Inclusions can be intrinsic or they can be extrinsic or intrinsic. And while polishing or cutting also, uh, inclusions can, it can spoil the diamond. And in the next one, I will show how clarity grading is done. Next slide, please. So, identifying inclusions needs skill. Besides, it is an art. Actually, one has to use a larger magnification microscope and mark on the picture. These pictures, these 3 pictures, just see the first one. On that, this is a please come back, 2-dimensional picture where each covered area covers a particular facet, and you can have pinpoints, you can have needle inclusions, you can have feathers, you can have cracks, graining, etc., etc. So if it is flawless, FL means flawless, and I have taken an example of grade F. Grades, diamond grades or color grades are marked from D, E, F, G, H up to Z. D for diamond, it is the starting one. And these are the best colors, D, E, F. And then the inclusions can be uh, uh, marked on this. Suppose inclusions are very few, like this that is shown here, that is called very, very, very small. And if you have large number of inclusions and cracks, then it is called I3. I tell you, price of an F grade 1 carat diamond from here to here maybe 2 times difference. Maybe, I'm not very sure. Whereas here it will be absolutely, ratio will be infinity, right? And if it is further inclusions are there, then its value will go down. The next one, please. So what I want to tell here, just keep it. What I want to tell here is that it needs a lot of experience. We are having a sort of I mean, thinking of a collaboration, initial talks began to have a database. All over the globe, people are trying well, spectral database and connect it to lower end instrumental data and get automatic grading. Some people claim they have made it already. We are in touch with IITM, we may. But at this point, I want to say that for the origin determination, on my initiative, we started uh, uh, developing machine language and normalization. Then we are our with just UV visible data, we are in a position to arrive at the origin, and our success rate is 97%, which is surrealistic. Fortunately, we have a large number of stones data. Therefore, we can be independent and we may develop in a matter of 5, 6 months. Yeah. Now, depth, that would be my contribution if I succeed. Depth profiling is another area which we have determined and published also. Being atomic energy trained person, radiation effects I understand pretty well. And if we can use this methodology to find out whether a diamond is treated with treated with radiation or not. So, as already I told, diamonds have 66% space, and there is a scope to accommodate other atoms or ions into this empty space. Next one, please. We all know that, next one, please, next slide. We all know that when the radiation, ionizing radiation like alpha, beta, gamma, or heavy ions, passes through the matter, it causes ionization, excitation, and radical formation. Besides, it can also cause dislocations. All these things can form intermediate energy states in the band gap region. Subsequently, the energy gap is reduced, and from purely UV region, they move to color region. So net result is color centers are formed and color is created. And lot of work is done on this, and globally, neutron is discouraged, use of neutron is discouraged, and electron beam is being used quite regularly to produce the volumetric color centers. If you have short range radiations like alpha or natural, that is natural radiation, both natural as well as artificial, as well as heavy ions, they will produce only skin deep centers. To make sure uniform color is produced, one has to treat further with HPHT treatment. But the best part of this is a signature at 741 nanometers, which is called grand radiation defect, will be there, and this can be monitored. What we have done is we have done a depth profiling, how deep the color centers are, which I quickly share with you and move on, which are useful to find out energy of the radiation and the extent of depth that has produced. Next one, please. So I am just giving 3 stones, about 25 stones we have done. These are all synthetic stones. Earlier we have done natural stones. So visible pictures are given on the top. Other 3 pictures are from the diamond view. Obviously this color tells that silicon is present. Next one, please. CBD, which is expected. See, what we have done is we have done the defect distribution as a function of depth. How it is done? Diamond is kept table up and the probe is brought in steps of 4 micrometers and the spectra are recorded. And here you just see there are about 100 spectra. First 3 spectra itself, the important peak, GR1, is getting reduced. That means in this case, the depth of the color is on the skin. That means either it is natural radiation or heavy ion radiation. But then what we have done is if it is natural, it should be patches on the surface. So we measured the depth profile in 4 different directions and every direction we produced at the same level. That means even after dealing with either natural or alpha or heavy ion, these are treated to get the annealed to get the uniform color. In the next click, you will see the conclusive. Next click, please. Here, what we have done is, in the first picture, if you see the first line shows the diamond line, which is independent for each. This is structural thing or two phonon line. And if you, that is constant and proportional to the diamond weight. If you take the ratio of these two peaks, intrinsic efficiency, extrinsic efficiency, and the angle dependence, etc., everything will be normalized. Therefore, what we have done is, after normalizing the peak areas, I have borrowed some data from the earlier paper on the natural diamonds. First two diamonds are showing a steep lowering down. That means the color is only up to about 7 micrometers. So obviously either heavy ions or alphas are used, and the rest of the things is in the background level. Whereas other three diamonds which are shown at the elevated level, this is due to electron treatment and annealing, because we have taken about four different directions. So it is having a volumetric color, and while seeing also they are beautiful. And the supplier who asked us to do this, and he said its value is pretty high. I don't know what is value. But this we have published last year, and after this publication, we are receiving samples from one or two samples from different countries also. Because many people run away from this because it involves a lot of work. Probably Parvadeganai, I don't know for others. Yeah, next one. But we take it as a challenge and do the service. Of course, we charge them. The next one is, we have some interest in understanding gemmological and geological aspects through spectroscopic studies of Indian rubies. We started with Tamil Nadu rubies. We collected 40 samples, nothing to do with the testing and certification. Along with that, we collected rocks and soil materials. Incidentally, in 1998, we published a paper on the geological origin of rubies, not knowing that I will be in GII one day. So same methodology we used here, except there we had a better techniques to get the elemental concentrations, whereas we have used here both XRF and UV visible. And this is the geological map. And out of 40 samples, 9 samples we explored, gave lots of interesting results. Next one, please. Next slide, please. Yeah, these are physical photographs. Next one, please. Yeah, UV visible spectrum is a very interesting thing. Normally, in any finished product, these are all rough stones. Any finished product, from any side, you get the more or less same absorption spectrum. But here we took at the physical center on the surface of the stone, and one at the extreme periphery. So we got different intensities, though peaks are same. It tells that the surface is influenced by the mineral. Then immediately we try to measure the concentrations in the soil. We have seen from the initial results, there is a degradation of concentration in the soil to concentration in the surface, central surface to the end, and in between rocks. There is a sort of gradient. That means migration is from the soil to the rocks to the central part, to the edge. So we are in a position to identify the geochemical process, but this work will take about an year or two, because as I told you, when we get the free time, only we can do such work. So, but this is very interesting. Next slide, please. Next slide, please. Yeah, these are all surface inclusions of different samples. I have given the number there, 1, 3, 7, 3, 7, and 5, different things. As I told you in the very beginning, because of the prevailing conditions, non-uniform color or color zoning can be there. That is seen in the last picture. Yeah, next one, please. As I told you, we have a Raman confocal microscope where we can move the probe to the inclusion which is done by general microscope and focus there, and corresponding Raman spectrum we can take, as well as the picture we can click through Raman confocal microscope. We saw feldspar in one of the rubies, and mica crystals in the other one, and phyroite in the other one. All these pictures could be characterized because of the Raman spectrum at that local point. This, I feel, is a very, very interesting work which we should be in a position to complete in a year's time. Next one, please. Just conclusion is from the preliminary investigations on nine rubies. High titanium content we have seen because of the rutile inclusions, high zirconium content because of zircon crystals. I don't know how all these such things, not very related ones, are existing. Samples are collected, showed surface impurities and mineral influence. Gemmological properties of these rubies align with typical values of corundum. That is one good point. And samples have various microscopic inclusions, as I showed some of them. Our observations clearly indicate that the samples are gem quality rubies and observed low vanadium and high iron. If you remember, earlier I showed some spectrum. They are similar to African rubies. Down south in India and Africa far away, I don't know what is the magic of the geology, which we will be working on. My last presentation is, next slide, please. We have seen, again, we do lots of testing of critical stones where no instrument could evolve in single step. Such things we call refer for further testing. On average, we get about 600 to 2000 stones per 600 to 1000 stones per week. In that, we saw 10 stones of, in one lot, 10 stones we tested, of which 2 diamonds showed orange fluorescence. These are all natural. First, we decide whether it is natural. First, we test that. Natural diamond showing the orange fluorescence. And other one is greenish fluorescence. Both could have shown only blue fluorescence. Then we went on testing for various possible defect centers by spectroscopic techniques. And also, we have not seen any phosphorance in our division probe. Hence, they are not LGDs. Natural diamond showing such an interesting patterns is scientifically very, very challenging. Yeah, next one. Proceed, please. Next one. So we have done one typical, one step back, please. I will not take more than 5 minutes total. Yeah, this, we have taken PL spectra of these 3 stones, and the intensity variations is intriguing, and all possible peaks in the samples we could explain. There is no GR1 or rather very weak that tells that it is not treated. Strong H4, that is 4 nitrogen atoms along 2 vacancies side by side, that tells that it stayed long time in the earth crust. And weak H3, that is 2 nitrogen atoms, it's a contrast to the earlier observation. Strong NO0, it is surviving, that is another contrast. All these things we should be in a position to explain in a few months' time, hopefully, and hopefully a journal will accept this. PL spectra are dominated by NV0 and H4 peaks, which is rather very peculiar. So we'll see how it goes on. Yeah, next one, please. So the observations, conclusions are, I would like to write as inconclusive. UV fluorescence features showed that the studied diamonds are natural colorless type 2A, although they are uncommon. All spectral observations are understood. We tried to analyze all the spectral features. No signatures of treatment. That is, GR1 is one of the criteria. Such uncommon green or orange fluorescence could be due to, we feel, subtle differences in lattice defect interactions and surface defects. This surface defects is a questionable thing. but could be. So no evidence of HPHT treatment or irradiation treatment or annealing treatment. All of them either leave a trail of signature or eat away one of the signatures. Therefore, all such possibilities we examined. Is interesting. We have to see further. Yeah. With this, my presentation is over. I summarize in the next slide just what I told. Causes of color in colored gemstones and diamonds is central, and I showed 2 slides. Scientific investigations are needed to develop test methods and protocols. So our testing comes first and scientific investigations just precede them. But out of some trained interest, we publish once in a while. Optical methods are used to investigate colored gemstones and diamonds, which I showed with some examples. 4C determination is important for diamond grading. Our investigations on Indian rupees suggested that they have similarities with African rupees. That is the point which you have to explain, along with the gradient in concentrations which is expected. Depth profiling suggests that the colored diamonds can be deciphered whether it is natural or induced. Thank you very much. I want to thank organizers for giving me this opportunity. My apologies. In the beginning, there was a delay and making some senior like our Mittal Sab to wait along with all others. And well, that's it. I ran through because of time constraint, though I don't believe in completing the syllabus. I taught in our training school for many years. I always used to tell, no, completion of syllabus is not a criteria, I used to tell. Yes, Mittal Sab, I know
Thank
you are
you.
ready.
Thank you, Dr. Reddy. We will take up some curious queries already in
Please,
line.
please, please, please.
Next 10 minutes, we shall take some
You
questions.
take any number of minutes, I don't have issue, but
Yeah,
you may have.
we have, I think this was already covered. Can the lab testing from Devaki Ramanathan, our trustee from IWSA, can the lab testing distinguish between natural diamonds and man-made diamonds?
Of course,
Yes.
yes.
Yeah.
Yes.
Of course, yes. I
Yeah.
said I invited. Devaki ji has joined a bit late.
Yeah.
You are welcome to come here. I will show, and we are proud that GIA has done this instrument development.
We have another question from Dr. Lali. Is it possible to find gemstones in Arunachal Pradesh river streams?
I just don't know. I don't.
Yeah.
I don't know. I will find out from the literature. I don't know.
Yeah.
Because our job starts from after receiving the gemstones. Yeah. Only this Tamil Nadu rubies is an exception. Out of my interest, we started. Yeah.
And what is the difference between natural and American diamonds from Dr. Paramjit Antappan?
Yeah. Natural diamonds are diamonds. American diamonds are cubic zirconia. That I just told in a passing remark. I developed a method to determine cubic zirconia in diamond powder and vice versa at sub-trace level. So American diamond is cubic zirconia, zirconium dioxide crystals.
Yeah. Our trustee Sunita Mahajan appreciates your very interesting lecture and your in-depth session. And we have Swati Gogate in the chat box. Can we identify diamond quality which is fitted in jewelry by using machines available at your facility?
Yeah.
Of course.
Yes, of course. Only thing is, that quick part is our now, if you talk about the studded jewelry, our size of the plate is 8 by 5 inches. So it should sit in that. So we have plans to make a bigger tray where we can keep the diamond there. So, jewelry. Yes, it can be done in about inside a minute to 2 minutes once it sits in the machine.
Yeah. And you have mentioned that because you know the composition now well, these can be the manipulations, everything can be judged.
That's about color stones. Yeah.
Color stones. Okay.
But still, nature is so complex.
Okay.
What we think we know, maybe that we don't know. There can be exceptions, what I want to say.
Yeah, Dr. Devaki Ramanathan asks, how do we as customer know if the diamonds we are paying for is natural or LGD? The shops only declare the customers for their diamonds. The prices will be very different. Declare the 4 Cs. Yeah.
Please demand for the certificate from a renowned institute like GII or GIA. Right? There are only a few institutes where they watch for the certificates. Such certificate you have to demand for.
Yeah. Yeah.
Without certificate, I advise not to purchase the high-end jewelry.
There is a question by B. Gopalan. Excellent lecture. I have two questions. How to test diamond studded in ornaments? Can natural diamond with minor inclusions be corrected in lab? I think.
Second part is no.
Uh,
The first part is, as I already answered,
yeah.
if that jewelry can reach our box, we can do. Otherwise, we have lasers, laser Raman spectrometer, which will test, which can be used to test whether the included diamond is natural or LGD or CZ. But then from there, we have to take an IR spec combination. If the size permits in one go in my instrument, you will know whether it is LGD or not. Just for 300
I mean
rupees.
the quick test kit, whatever, the quick test instrument, what you are giving, can we use that for identifying the studded jewels? That's right.
That is the thing I said. If the size permits, see, my platform where we spread the diamonds is about 8 by 5 inches. Now, if I can, suppose if it is a necklace, I can fold and keep. If it is thick necklace, then we cannot meddle with it. In such cases, by part, we can do using the Raman as well as IR. Yes, it takes a lot of time. Whereas if the size, suppose you talk about a bangle, I can do in 30 seconds and tell you, bangle studded with jewelry or an foldable necklace, something like this, very easy to find out. Yes, we can do.
Then there are again appreciations coming in from Ram Vinod Gupta, retired from HWB, our old association through, yeah. So he wants to, appreciate you. And our Dr. Sheila Donde, our senior scientist in IWSA. Excellent lecture, learned a lot, but I have to leave now for some other appointments. Dr. Ramanathan, Devaki Ramanathan hopes to visit your lab with all of us.
Even tomorrow.
Yeah.
But
Any
you
other
have to give
questions?
me a notice of at least 4 days.
Okay.
Not even 4 days.
Okay.
We have to get an entry for you.
There is
And
another question from Bushra. What qualifications are required to become a gemologist?
To become a gemologist?
Yes.
No qualification. I am an example.
Yes.
I am a chemist who is dabbling with the nuclear science.
Yeah, very good chemist.
Mithal Jaisa Bada Saab pushed me into analytical
Yeah, I
chemistry.
said you are a very good chemist.
Nice, sir. And then from there, from solution, I am frozen into solid state by my friend Dr. Shastri.
That's why I'm telling you, you can cover.
So
Everything
I
is
have become a
chemistry.
solid state physicist now.
Everything is chemistry.
Yeah. Without a doubt.
Yeah.
And I always used to tell, analytical chemistry is the central for experimental science.
That's it.
Yeah.
Whatever kind of chemist you are.
Okay.
Yeah. Your blessing, sir.
Yeah. Our senior scientist, Dr. Meera Venkatesh, wants to thank you for this interesting.
Senior scientist, she is my batchmate.
You
and
mentioned
friend.
that you can place the diamonds to evaluate the quality. I presume the diamonds need to be as separate stones and cannot be already set in a jewel. I think that's a doubt he wants to clarify.
By the way, incidentally, Meera and myself and Shamla are batchmates.
Okay.
But I am elder to them.
Yeah. So all your classmates are here. Yeah, so she wants to clarify this. The diamonds
Meera.
need to be separate stone. Yes.
Yes.
Meera,
Reddy,
what is the question?
I see you had shown a picture with diamonds in under the, I don't know if it's a microscope or some kind of an instrument to test its quality, etc. So when a diamond is already set in a jewel, then you cannot measure such things, right?
Not easy.
Same system and with the same speed. We can do.
We can do it. Okay.
Of course,
Good.
And our income see, we have to earn and pay the people. Our income is mainly from origin. Next best income is from the jewelry, studded jewelry.
Yeah.
We can do.
Oh, that is very interesting.
We do. Only thing it cannot be quick if it cannot be fitted into our machine. For grading, absolutely no issue.
Okay. Okay. Thank you. Thank you.
Okay, I
Can
think
I
we
take
have
a
taken up
question,
most.
Priya?
Okay, ma'am. Sureka, Dr. Sureka
Dr.
Singh,
Reddy,
our trustee.
Sureka ji,
is
boliye.
there a database for different diamonds from different parts of the world? Is
It
there a
is available.
database?
It is available on that is something called Rappaport.
Mhm.
They provide. Yes, it is available. It's one office
Is
is there
it
in premises
all
also.
with the spectra and all available on that?
No.
Yeah.
Nobody will part with them.
So what
But
the
general,
database contains?
what you get in Wikipedia, you get a bit more. But many
Okay.
people, critical spectra will not be there. Even my own depth profiling spectra, etc., I won't show. In fact, if Mithalsav's permission, I will talk.
Hmm.
2 years back in UK, I was giving an invited talk on diamond spectroscopy and what could be the future on doubling of energy. I gave some
Yes.
something I expressed openly. One GIA person told you did a mistake. In 8 months' time, that was published by them. So nobody would like to share. Though, if you come here, we will show.
Okay. All right. Thank you.
So database is not accessible for many things, but GIA has a way, Gemmological Institute of America, they give you a number if you test, like we also give. And with that number and ID, you can see your spectrum
Okay.
anytime from anywhere, whether it is by us or by them. Okay. Yeah.
Thank you
But
so
Thank
much.
you.
generality, you have a database on generalities,
Yeah.
right? It's not like textbook matter.
Okay.
Yeah. Yeah.
Sir,
But-
very nice lecture. Very
Dr. Sunita Mahajan. Okay.
Yeah, you know, madam taught me computers. One of the best teachers. She is one of the best teachers.
Thank
She
you.
taught us computers. Yeah. Bole, madam.
Very nice.
You are muted, I think. Madam, you are muted. Sunita ma'am, you are muted.
No,
Now we can hear you.
Yeah, please.
I'm saying it was a very interesting lecture, and thanks for giving such a nice talk. Thanks for saying that
As I always tell, because of Mahajan madam, we learned computer programming. So I should thank you also. This now I am dabbling with a bit at the periphery on AI. Again, thanks
I
to
see.
you. Initiation was by you.
Thank you.
In 76, 77, 78, 3 years.
Uh-huh.
I used to come regularly to you and Mrs. Kamath.
Ah.
Yeah. Boliye.
So you were very young at that time, so now I don't remember.
Mentally, I am young even now. Boliye. Jokes
Dr. Reddy
apart.
garu, this is Gopalan here from Hyderabad, retired from
Yeah.
NLC.
Boliye.
So I have met you in Dr. M.D. Shastri's, whenever you used to come there, you were
Correct.
editing the other transit, that journal also, that radiochemistry. It was very useful and all. So I just wanted to know this cost of the equipment which that users can, that shopkeepers can use it. So you told two types of equipment. So how
Yeah.
much approximately it costs?
The latest one costs about 6.5 lakhs,
Okay.
whereas equivalent American thing costs about 22 lakhs. And equivalent UK one costs about 28 lakhs. So we have a control. I mean, we are controlled by a board of trustees who are all gem and jewelry industrialists, and they say that this institute for G&J by G&J industry. Therefore, testing rates and the cost of equipment have to be controlled, decided by them.
Now, another thing is how to correlate your data with, see, when they give the quality, they give that VH, then that is one type of quality they give, then there is another type of quality, and how to correlate all the three certificates, which is
See,
they are showing.
generally, sorry, is the question complete?
Yeah.
Generally, if you are talking about diamonds, the inclusion, again, clarity. That is flawless, then very small inclusions, very, very small inclusions. In that also 2 divisions. This is GAA method. There is another method using by combining 3, 4. That is industrial method. So some people give 3, 4 things clubbed together. Essentially, other than FL, there is bunching of the things. FL is uniform to everybody, flawless. Like you got 100%, this is unique, right? So there is nothing like correlation, but yeah, there is a correlation. But you know that, John, if you specifically write this, I can write you back because I have both the scales with me. There's no issue about it. If it is diamonds, for diamonds, yeah.
Can we conclude the session? I think we have taken quite a lot of questions. Thank you, Dr. Reddy, for shedding light on this captivating subject and enriching our understanding. We appreciate your time and expertise. We now know that diamonds are not just a girl's best friend, but also the best puzzle that dazzles scientists. With this, we conclude today's session. Thank you all for your participation and have a good night. Thank you, sir.
Generous in complimenting. Hope something is conveyed properly.